Hello everyone, again you are watching mahafarka.co.in. Welcome back. In this video we are going to deal with one of the important article again, that is about radioactivity. Now to learn this article we should revise what exactly is binding energy per nucleon and what that curve indicates. If you remember, binding energy per nucleon if the energy which holds the entire nucleus close to all the nucleons close to each other. Now this binding energy per nucleon defines whether the nucleus is stable or not. This binding energy per unit nucleon decides whether the nucleus is stable or not. Remember, higher the value of binding energy, higher is the stability of the nucleus, higher is the stability, and vice versa. Means what? Lower is the value of binding energy, lower the value of what? Binding energy, lower is the stability. Again, if you remember from the binding energy per unit nucleon curve, according to that curve, for element with atomic mass equal to 30,207, atomic mass equal to 30,207, this binding energy per unit nucleon is always remains constant. It is almost remains constant. It is highest for A equal to 56 and A equal to 170. It is having highest value. So we can say that element whose mass number belongs to 30 to 170 are quite stable element. They are quite stable nucleus. Whereas element with mass less than 30 and greater than 170, element with mass less than 30 and greater than what? 170 are not stable. So we consider them unstable nuclei. Now this unstable nuclei also wants to become stable. For making them stable, some changes within them should be takes place. त्यांच्यामध्ये changes होणं गरजेचं आहे. What type of changes can be takes place there? Then see, if any nuclei with atomic mass greater than 170, we will call them heavier nuclei. As it is heavier nuclei, the instability of their atomic structure will be stabilized by splitting this heavier nuclei into lighter nuclei, Element with atomic mass less than 30, will be considered as which nuclei? Lighter nuclei. And now what they will do? That lighter nuclei, to become stable, will recombine into heavier nuclei. During this process, energy is emitted. And the reactions which produces these two things is called nuclear fission and nuclear fusion reaction. This was the important term that we need to recall to understand the radioactivity. Now we'll come to exact radioactivity. So what is radioactivity in short? See, I said now heavier nuclei cannot have stability. To maintain the stability, they have to lose their own nuclei. या प्रोसेस मध्ये there is a spontaneous emission. There is what? Spontaneous emission of that substance or mass of the substance if it takes place. This spontaneous emission of mass of substance is considered as radioactivity. Is considered as what? Radioactivity. Okay. Now, what is going to happen exactly in the radioactivity? Suppose element X is heavy nuclei. So I will call that element X as what? Parent nuclei. It will disintegrate. It will what? Disintegrate. Disintegrate होईल म्हणजे काय होईल? It will split automatically into small parts. It will automatically split into small parts into say more than two, say Y and Z. So these Y and Z are outcome from X which is spontaneously emitted, and so Y and Z can be called as what? Daughter nuclei. Y and Z can be called as what? Daughter nuclei. So this process is called as a radioactivity. During process of radioactivity, large amount of energy is emitted. This amount of energy can be for example, if that is emitted for proton, then it is around 940 mega electron volt. Remember, this is tremendously high energy. So during process of radioactivity, every substance, those who are having atomic mass greater than 170, they split. They are considered as heavier nuclei, so they split into lighter nuclei. During splitting into lighter nuclei, they radiate the energy, they emit the energy. That energy emitted or radiated depends upon the composition of that nucleus. So that nucleus we are going to call it as parent nucleus, and the element or the nucleus which is going to form after decaying process, then we are going to call it as a daughter nuclei. So this disintegration is also considered as decaying process. Decaying च्या एकदम सोप्या अर्थात एक ऑब्जेक्ट तुमच्याकडे आहे, थोड्या दिवसांनी तो त्याच्या स्वतःहून मास कमी करत जातोय. दिस प्रोसेस कॅन बी कन्सिडर्ड as what? Disintegration. So how many types of disintegration can be takes place? Then remember there are three types of disintegration. First is alpha decay, second is beta decay, and third is a gamma decay. Alpha, beta and gamma decay खूप महत्त्वाचे decay आहेत. So let's learn them in a detail. So let's learn first about alpha decay. So what is alpha decay? Every element whose atomic mass is greater than 210 undergoes alpha decay. In alpha decay, the parent atom loses 2 proton and 2 neutron. So if X is any element with atomic mass A and mass number Z, then Z is decreased by 2, A is decreased by 4. So this helium atom 2He4, this helium atom which is emitted from any element with atomic number greater than 210, this one helium atom is called as alpha particle, and the corresponding decay is called as alpha decay. In the alpha decay, atomic number decreases by 2 and mass number decreases by 4. So total number of proton decreases by 2, but proton and 2 proton plus 2 neutron, that is total mass decreases by 4. Okay. Now they possess ionization power. What is ionization power? So if very sharp beam of alpha particles is allowed to pass through any gas, then it will bombard on the gas. The nucleus of the gas will split so that the positive and negative ions will be separated. So this process we can call in short as ionization. So when alpha particles are falling through or passing through any gas, they can ionize the given gas. They affect photographic plates, and finally, as they have charged particles, what should be the charge on that alpha particle? See, 2 protons are there. So altogether 2 protons plus 2 neutrons. So charge on 1 proton is what? Plus 1.6 into 10 raised to minus 19 coulomb. So total alpha particle will have charge plus 3.2 into 10 raised to minus 19 coulomb. Remember, so this is high charge plus 3.2 into 10 raised to minus 19 coulomb will be the charge on alpha particle. So they have positive charge. As they have positive charge, they deflect by electric field as well as what? Magnetic field. Okay. They have positive charge, because of that they deflected by electric as well as what? Magnetic field. If you put any element of value of atomic mass greater than 210 here, then त्या element साठी तुम्हाला इथे reaction लिहिता येईल. This is the general formula for alpha decay. Now what exactly happens in a beta decay? So remember, we know that nuclear force, it tries to balance the nuclei, it tries to maintain the nucleus in the equilibrium state. For that, nuclear forces are act in a such manner that the electron should be emitted from the nucleus. Now how it is possible to understand that? Emission of electron during conversion of proton to neutron is called as beta decay. न्यूक्लियस मध्ये प्रेझेंट असणारा प्रोटॉन अँड न्यूट्रॉन, दे इंटरचेंज देअर चार्जेस. प्रोटॉन कन्वर्ट्स into neutron. During this process, positive charge of proton is excess. To balance this, one negative charge is again there, that is called antineutrino. That antineutrino should be present, and that antineutrino is releasing from that, and this we consider as what? Beta decay. So emission of electron during conversion of proton to neutron is called as what? Beta decay. And one particle which is emitted there is called a beta particle. So याच्यात काय होणार आहे बघा, Z is increased by 1. So to increase this, number of electrons should be decreased by 1. So n decreased by, so n म्हणजे number of electron म्हणूया आपण, n decreased by 1 म्हणूया. So n should be reduced by 1. एक प्रोटॉन वाला तर एक न्यूट्रॉन तिथे, एक इलेक्ट्रॉन तिथे कमी होणं गरजेचं आहे. So for that we will call it is what? Beta decay. Like alpha decay, beta decay also possess ionization power. They also affect photographic plate, and they also deflected by electric and magnetic field. But the ionization power of alpha decay is quite higher than that of beta decay. In short, if I write, if alpha decay has power 1 times, then beta decay will have that same power 1 by 100 times. Okay. Now, what is gamma decay? Then if you go through the previous lesson in which we have learned that when light falls on some photosensitive materials, electrons are emitted. So that light consisting of some particles, according to Albert Einstein, तुम्हाला जर आठवत असेल, then we have called those particles are the particles which are having discrete energy levels, and we call them as photons. When such photons are emitted by any material, then we call them highly energetic photon, are called as what? Gamma decay. During emission of that, no changes are takes place in the parent atom, so no change in Z and A is also takes place. Gamma decay also possesses penetration power. Gamma decay also affects photographic plate. Gamma decay do not deflect by electric and magnetic field. Logic एकदम सोपा है. It is photon. Photon is a chargeless and massless when it is at rest. So it has mass only when it is in a motion. So highly accelerated particle is called as photon. त्या फोटॉनला जर तुम्ही इलेक्ट्रिक फील्ड आणि मॅग्नेटिक फील्ड मधनं पास केलं तर त्याच्यावरती चार्ज नाही, therefore it will not get deflected also. So this is the decay. I hope you understood this. These are very important and I have written everything in a very shortcut form. तुम्हाला MHTCET ला हे खूप महत्त्वाचं काम करणार आहे. एवढ्या सगळ्या गोष्टी जर तुम्हाला लक्षात आल्या तर तुम्हाला तुमचे प्रिपरेशन करायला सोपं जाणार आहे. I hope you understood this also. Thanks for watching mahasarkar.co.in. Thank you.